Jai Hind everyone. Welcome to the class of Data Communication Network under Unit 4. In today's video lecture, we will discuss two topics. First is network layer design issues, and the second topic that we will cover is types of IP addressing, or what are the different IP addresses that we can use with the data communication network, like IP version 4 and IP version 6. So, as discussed, the main contents for today's presentation will be: first topic related to, we will discuss in detail what are the various design issues that must be taken care of for the network layer, and in the second we will discuss, as a part of network we require IP address. So, what are the different categories or types of IP addressing schemes that can be used with the network? Most popular IP addressing scheme or techniques are IP address version 4 and IP address version 6. So, we will cover these both in the coming slides. So, first topic is network layer design issues. Basically, we know that the detailed function or proper functioning of the network is defined through the network models. So, the popular models are like OSI model and TCP IP model. So, in this there is a layer known as the network layer, and we know that this network layer is mainly responsible for the efficient and reliable transmission of data across the network. The main features that are provided by this network layer are, for example, maybe the routing, or we can say that flow control, or we can also say that the traffic or congestion is also maintained or managed by this network layer. So, in the network layer we can also say that this is also responsible for congestion control. Along with congestion control, we can also say that the quality of service is also controlled by this network layer. So, what are the main design issues that must be taken care for this network layer, so that our data communication network is efficient or best, or that can provide the efficient and reliable transmission of data across the network? So, the first design issue that must be taken care is scalability. Scalability means when we increase the network scale from small network to a large network. That is, whenever we increase the number of devices and traffic volume, with the increase in the number of devices connected with the network or traffic volume, the network must be able to handle it without the degradation in the performance. So, this is the meaning of scalability. That means whenever the additional number of devices are connected with the network, or more and more traffic is added to the network, there should be no degradation in the performance, or the network should be able to handle that increasing scalability. So, to achieve this involves the efficient routing algorithms and network addressing schemes. That means to achieve this scalability, we have to use the efficient routing algorithms and network addressing schemes. The second most important design issue that must be taken care of is reliability. Reliability means even in the case of failure, or even in the case of potential failure or congestion, when the congestion is crucial, in that case the data should be transmitted reliably across the network. That means even in the case of failure, or whenever there is congestion or too much traffic volume, in that case network should not fail, it should reliably transmit the data across the network. So, to ensure the reliability, we have to use some kind of error detection and correction mechanisms, as well as protocols for retransmission of lost or corrupted data. That means to ensure the reliability, we have to use some error detection scheme, error correction scheme, some advanced protocols, as well as we have to use some retransmission of lost of corrupted data. Next design issue that must be taken care of is performance. Designing for optimal performance involves minimizing the latency, that is delay. Latency is also known as the delay. We know that the network should transmit the data from one place to another place in a real time, or there should be minimum delay or latency. So a performance of the network will be optimized when we will say that the latency is minimum, throughput or output data transfer is maximum, and it efficiently utilizes the network resources. So to make the performance efficient, we have to take care of that prioritizing of different traffic. So some data traffic may be of low priority, some data traffic may be of very high priority. So we have to manage the congestion by prioritizing the traffic. So high priority traffic must be transferred first, and low priority traffic must be transferred later on. And if we have to discard, so the low priority data can be discarded to maintain the congestion. Moreover, optimization algorithms, that is routing algorithms, can be implemented to improve the performance, and quality of service schemes can also be implemented to improve the overall performance of the network. Some more design issues that must be taken care in the network layer are: next important design issue is security. Security means nowadays security is very important for the network. Now a number of devices, let's say mobile or computers, are connected with the network. So security of the network is very important. So for security means protecting the network from the unauthorized access and data breaches and other security threat is essential. So network must be protected from unauthorized access. Nobody should be able to access the network without the permission, or only the authentic user should be able to use the network. Then there should be no breach of data, data protection should be there, and all other security threats must also be taken care. Now to implement this, we have to use some kind of encryption, that is encryption decryption schemes. We have to use authentication process, that is, and access control. That means only the limited and authorized users which can be given access to the network. So there should be some authentication checking mechanism that the user which want to access the network, whether that user is authentic or not. Only the authentic user should be able to access the network. To achieve this, we can also implement the prevention mechanisms, detection mechanisms. Next important design issue is flexibility. The networking layer design should be flexible enough to accommodate the diverse network architectures or technologies and protocols. So network should be flexible in adopting the technologies, protocols and networks which are of diverse nature. So different types of architectures, protocols and networks must be able to converge with each other. So this is flexibility. This flexibility allows the interoperability between the different network devices and systems. So if different type of networks, different type of protocols and different types of technologies are able to merge with each other, this will enhance the possibility of interoperability between the devices and the systems. Next is manageability. Nowadays it is very important that network should be managed from the remote. So the designing for easy management and maintenance of the network simplifies the operation and reduces the likelihood of errors. That means nowadays the network should be designed in such a way that its operation, maintenance and troubleshooting etc. can be controlled with the remote. So it should be easily manageable. So manageability of the network layer is also very important. To achieve this, we have to use, for example, we can add on the remote configuration, monitoring and troubleshooting tools. So during the designing of network layer for a network, we should ensure that the manageability is very good and there should be features of remote configuration, remote monitoring and troubleshooting, and maybe also the management can also be done using the online tools and using through the softwares. Next important design issue is compatibility. Ensuring compatibility with the existing network infrastructure and protocols is very important for seamless integration and interoperability. That means whenever we are designing any new network, that should be compatible with the already existing infrastructure, network and protocols, so that the old network can also be utilized. The users or customers of old network can also be accommodated with the new network. So there should be compatibility between the new proposed network and the existing network, so that there is seamless transition. So by addressing these design issues, we require careful planning, analysis and implementation of networking protocols, algorithm and technologies. That means for efficient transmission of data across the network, over the network, these design issues must be taken care of. If these are taken care, then the performance will automatically be better. So next important topic that we are going to cover is IP addressing. IP address categories or types. Basically, we know that any device, for example a mobile or a computer that is connected with the network always assign its an identity. That unique identity is known as the IP address. So basically IP address is the unique address assigned to device when connected with network, when connected with network. That means whenever any device is connected with the network assign its a unique identity. That unique identity is known as the IP address. So IP addresses are generally divided into two types or two categories. The popular ones are IP version 4 and IP version 6. So in this first part we are going to cover is IP address 4. So basically IP address version 4 is a 32-bit address. It has some feature like it is unique. IP addresses are unique and universally defines the connection over the network for a device. For example, a computer, a router or a mobile, whenever it is connected with the network, a unique identity or address is assigned to that device, and this is known as the IP address. Now the IP address can be assigned from the IP version 4 or IP version 6. Earlier there was IP version 4 and later on advanced version came, that is IP version 6, because there has some limitations with the IP version 4. The number of devices that can be connected with the network are increasing with the day by day. So we require more and more number of IP addresses. So IP version 4 is not able to provide such large number of IP addresses. That's why we have moved from IP version to IP version 6. We know that the future is IoT. In the IoT, every device will be connected with the internet. If all devices are connected with the internet, then all devices must be assigned the IP address. Now the IP version 4 will not be able to fulfill that requirement. So we will require the IP version 6. So some features for the IP version 4, that is IP version 4 is 32-bit address, 32-bit long. Another feature is IP address are unique and universal. Okay, so whenever a device is connected with the any network, a unique address will be provided to it that cannot be assigned to anyone else, and it will be universal throughout the complete network. So what is the address space or total number of IP addresses that can be provided into the IP version 4? We know that the IP version 4 is 32-bit long address. So total address space or total number of IP address will be 2 raised to power 32. So this is the total size of address space that can be connected with the network. Okay, so beyond this we will be requiring IP version 6. Now the notation, the IP version 4 basically we have studied it is 32-bit, or we can say that it is 4 bytes. So 4 bytes means it is divided into 4 subparts. That's why it is known as the IP version 4. Now this IP address, IP version 4 can be denoted either in the decimal form, decimal notation, or maybe in the binary notation. So one example is shown here. This is the first byte in binary notation. This is the second byte in the binary notation, and this is the third byte in the binary notation, and this is the fourth byte in the binary notation. So these are the first byte, second byte, third byte, and fourth byte, and total is 32-bit. As each subpart is of 8-bit, so maximum value is 2 raised to power 8, that is 256. So the value can be assigned is 0 to 255. So whenever we will use the decimal notation, the maximum number that can be used is to represent the IP address is 255, and minimum number is 0. So corresponding to this is 128, second 11, 3 and 31. Basically when we convert binary into decimal, we consider only the one part. For this case we will cover only these two, for this we will cover only these three, for this we will cover only these, for this we will cover all. Okay. So we can replace the binary notation of the IP version 4 into the corresponding decimal notation. One example is shown. So each group of binary bits is replaced by its equivalent decimal, and This is the maximum possible value, and as I have discussed in the previous slide, the maximum possible value is 2 raised to power 8. So we'll 0 to 255. So maximum allowed number is 255. So here we have 255. So binary to decimal notation can be converted, or decimal to binary notation can also be converted. Let's see one more example. This is another example where this is the IP addressing version 4 into the decimal notation, and this is the corresponding binary. So each decimal number is converted into its corresponding binary value. So binary to decimal and decimal to binary conversion can also be done with the IP address version 4. That is, IP version 4 can be denoted either in the decimal version or maybe in the binary version. There is an example. In this example, there are some errors in the IP version 4 addresses that I have mentioned over here. So we have to find what are the errors. So in the first case, we can see that it's okay. It is also okay. In this case here, the initial 0 is not allowed. Initial 0 is not allowed. So instead of 045, it should have been only the 45. Let's see second case. In this case, we have 1, it's okay, it is also okay, it is also okay, it is also okay, it is also okay. But there are 1, 2, 3, 4, 5 bytes. So 5 bytes are not allowed. In the case of IP version 4, as I have discussed, there should be only at max 4 bytes or 32 bits. So one of them is extra. Maybe let's say this last one. Okay. Let's review this third IP address. This okay, it's okay, and this value 301, this is not okay. As I have discussed, the maximum allowed value in decimal notation is 255. So as 301 is greater than 255, hence it is not allowed. In the last case, let's see. Here we have binary, then we have decimal. It is binary, it is decimal. So this is the mixed notation. Mixed notation is also not allowed. Mixed notation not allowed. Either we can use binary notation or we can use the decimal notation. Mixing of both notation or using of both notation is not allowed. So this mixed notation is there in this IP address. So this IP address is also not correct. These IP addresses in the IP version 4 are divided into various classes. These classes are class A address, class B address, class C, class D and class E. Let's see how these are differentiated. In the first byte, if there is only single byte 0, initial byte, then it is class A, it is 10, class B, it is 110, class C, 1110, it is class D, all 4 ones, it is class E. And in decimal form, there is a range defined. In this range, we will say class A, in this range class B, this is class C, and this is class D, and this is class E. So range wise we have divided into class A, B and C and D, so that different applications or different things can be performed over the different classes. So the classes of IP address version 4 can be used application here. Unicast communication application can be used over the classes A, B, C, whereas multicast applications use the IP address version for class D, whereas class E of IP version 4 is reserved for future applications. By classful addressing, we can see that a large number of addresses gets wasted. So these should be avoided. So nowadays we have moved from classes at classful addresses to non-class addresses. So along with the IP address, we also use the mask, also known as the default mask. Basically, this is to identify whether the host computer is over a local network or within the part of same network or a different network. So to provide this with the decimal notation, we provide this type of mask. These are the default mask. For class A, it is 255, for class B, this one, for class C, this one. So as I have discussed, the classful addressing, which is the almost obsolete now, is replaced with the classless addressing, because in the when we divide the IP address into the different classes, a large number of IP addresses gets wasted or they are not utilized properly. Similarly, there is IP version 6. As I have discussed, in the IP version 4, there are limited number of IP addresses range. Nowadays, with the IoT, all devices will be connected with the internet. So as the IP addresses are limited, so it will not be possible that all devices may get the IP address. So future is expansion of IP address or range of IP address should be increased. The future lies with the IP address version 6. So as IP version 4 was only 32-bit, whereas the IP version 6 will be 128-bit long. So we can see the huge difference. The number of IP address will be now 2 raised to power 128. Okay. So as discussed, the new IP version 6 will be 128-bit long. Now the notation, as we have discussed for the IP version 4, the IP version 4 used the notation in the binary form and decimal form, whereas in the case of IP version 6, we will be using binary and hexadecimal notation. Binary and hexadecimal notation, because the binary is always the preferred for the digital, but hexadecimal code is preferred because it is the most compact code. That is, a large range can be represented with only the limited number of characters, because we know that each hex character is equivalent to 4 binary bits. So as it is the most compact code, so in this case we will use the binary and hexadecimal colon notation. So basically the subparts will be separated from each other by the colon. For the separation, in the IP version 4, for separation, what we are using the dot. And in the IP version 6, for separation, we will use the colon. So we can see that it is 128 bit. 128 bit equal to 16 bytes. 16 bytes or 32 hexadecimal digits. Okay. So here we have shown the hex notation, and it is 32 bit. So 32 bit means 32 hex digit means 32 bit hex digit means 8 into 4. Okay, yeah, so if we represent the 4 hex character here, so this will be part 1, 2, 3, 4, 5, 6, 7 and 8. So there will be 8 subparts and each part having 4 hexadecimal digits or hexadecimal characters. So there will be 8 subparts in the hexadecimal notation and total size 128 bytes or 32 hex digits, and these are separated by the colon. So one example is shown here. Now this notation can be minimized further by expressing this, representing this 4 binary bits with the 0. This can also be with the 0. This can also be with the 0. This can also be represented with the 0. Now to further compress this, as these two subparts are equivalent to 0, so this can be simply denoted by space. Space means in between the sub parts are 0. So this is shown in the next slide. So this is the abbreviations used for the IP version 6. So this is the original IP address in the version 6. It is using the hexadecimal notation with spacing by the colon, and then these zeros are converted into single zeros, and these zeros and are finally replaced with the gap or space. So these are the different IP version 4 uses. That IP version 4 128 bit address can be used for unicast address. It can also be used for multicast address. So some frame structure will be changed for this IP addressing. Then reserved category can also be there. We can also provide local address for the IP version 6. So this is shown in this slide. Local address is in the IP version 6. So that's all for this lecture. Thank you everyone. Jai Hind. References are shown here.